Ooh, it is time to start a new video. We will be doing linked lists today. Holy crap, I did a lot of editing, I'll tell you guys about it, but we are going to be doing some stuff with linked lists today. And I definitely will not be doing all of these. Like, everything you could possibly do with these programming challenges, I'm pretty sure linked lists are like the most useless thing that there is. I don't know, I've never ever remotely heard or worked with linked lists in an actual programming application. And I'll say this much, I also haven't worked with heaps, but I at least heard, like, what is this, bro? You're working at like the memory level with these? Maybe not, I guess not. But like, you're working with addresses and shit, and oh my god, it's just ridiculous. I haven't uploaded, so I uploaded a bunch of videos today, which will be some other time in the future when you guys see this video, but I literally published like 4 or 5 videos today. I was just absolutely going ham with the editing and shit. I've had like so much content just stored up. Without further ado, let's get into the absolute easiest question that they have. Alright, given a pointer to the head of a linked list, insert a new node before the head. The next value in the new node should point to head. And the data value should be replaced with a given value. Definitely an instructions following simulated question, but it's fine. Damn, I got so much snot. Sinuses have just been draining, man. Oh, so y'all didn't see that. Alright, so let's start this off by just printing out the input. I decided after a lot of soul searching that I will be copping myself a new ergonomic keyboard. And it's definitely going to be a split keyboard layout, and I'm actually going to learn how to properly type, because for years I've been typing with some weird hybrid of chicken pecking / actually proper form, and it's just done me so dirty. Alright, so they pass us a bunch of linked lists, and really, okay, so the list actually starts off as empty, huh? Okay, so how do you actually... I don't quite comprehend. First of all, how do I even add a node? Oh my god, alright. Well, there's no reason tormenting myself. Singly linked list node. Yeah, see, this was never going to happen. And why do these people have different fucking parameters than I do? Singly linked list node. Okay, that's pretty simple. Alright, let's see what we can do with this. You know what, I'm just going to try to take this... I'm going to just try to take this back to the question so that I'm actually, like, practicing. Node is equal to singly linked list. Okay. Is there, like, a list and node? There is, okay. Fuck off. And what do I do from here? I don't know. I really don't. Huge disproponent, or what the fuck? Huge adversary of linked lists, man, just in general. I mean, yes, they're a helpful data type, but like, do I really need to be building the support to build these? So, the leaderboard, the session board, says we pass data into the node. Alright. and we say node dot next for some reason is equal to node. I bet you that's the answer, isn't it? Oh, it's equal to head. The node dot next is equal to head. I mean, I don't quite follow. Node dot next. I really don't follow. List equals new node. New node dot next is equal to the list. I don't want to do this. This shit's so stupid. I'm tired of doing this shit, man. I like projects. I like fucking building shit. I like doing stuff. This is so fucking annoying. This is completely backwards from how I've learned programming for so long now. My entire programming career has literally been only project based, okay? I have like 130 pages of notes stacked away somewhere, but like those notes are on things I needed to know in order to do a project. This is just painful. Like I feel like, oh man. All right, well it's pretty obvious that I don't know enough about linked lists to be doing this, so I'm gonna go on YouTube and learn about linked lists. All right, so linked lists are not too difficult. Very simple premise behind them. The one thing that I'm not understanding is why am I able to say something like node.next equals L linked list? Like, what I'm wondering is where is this memory address coming from? Because I'm not storing that anywhere. Am I referencing what is a list? What is this? I mean, I get the concept that I'm making the next, like I'm pointing towards the next node, which is somehow the list, but like, am I pointing towards its memory address? Where is its memory address coming from? Which element of the linked list am I referencing? It's just, there's a lot that I'm not understanding there, and I'm not appreciating this. I'm not in the mood to be doing this today. Alright, whatever. That's over with. And somehow it's not. I wonder how you could possibly fail a test case on this. Watch me fail a test case. I'll be so pissed. Live here. Thank you. Alright, let's go. We're going to delete a node. I feel like I should probably do this really quick just to get it down. So, the list is the head position, I assume. And it wants me to delete position 2, 0, 1, 2, so it's 0 indexed. Is position, I'm confused if position, alright, here, you know what, when you're confused about the input of a problem, you know what you do this. You say, list, and you fucking print out list, right, and then you say, position, this is position, and what did that? So what's up next? Alright, so this is pointing to the next thing, position 3. And the expected output, it expects me to keep track of all of the data or something? Returns. So the last one didn't even have a return. a reference to the head of the modified list. Alright, so I literally just returned the list, I think. Alright. Index equals 0 while index is less than position Alright. Current node is equal to let's start off with a little list here actually. Current node equals what, node.next equals Can I chain dot next? I feel like I can. But I need the pointer. Is this a dumb way to implement this? Because I feel like it is. Whatever. I'm gonna run this and see what I can do. One of them passed, and the condition can't even work. That's so weird. How does that even work? Eight. 1, 2, 3, 4, 5, 6, 7, 8. It wants me to remove 3. And if I remove 3, it wants me to remove the thing at 3. Oh, the thing at 3 is 26, 2. Shouldn't I remove 2? 2, 19. 1, 2, 3. 0, 1, 2, 3. 0 indexed. So then I say equals. Yeah, no, that doesn't make sense. I don't know how the fuck that just happened. 2, 6, 19. So just 0, 1, 2. 0, 1, 2, 3. Wait, so what did I do wrong? Well, now it's not 0 indexed. What the fuck do you mean? Should be 2, 6, 2, 7. 2627. Alright, let's step. So we start off. Index is 0. The current node is equal to the pointer that we're currently looking at, while the index is less than or equal to the position. The position is 3. Current node equals the list.next, and that means we're looking at the next thing. So now we're looking at 6, and the index is 1. Then we're going to look at 2. We're going to look at 2. Wait, hold on. 26, 2. We're at index 3. Oh, but I wanted it to stop at... I wanted it to stop at, what, 2 in this case? Yeah, I wanted it to stop at 2, which is 3. So, while index is less than position, it'll be less than position at 2. So this should stop executing at 2. The start node is equal to the current node. Our current node at this point should be our 2. Yeah? The end node should be current node dot next 7. 2 and 7. Start node should equal 7. Alright, well, I don't actually see what's going wrong here. I can't fathom what's going on right now. 2619. So, can I just print the fucking data or something? Oh, dude. Well, that's cute. Maybe that's why. Alright, so we wanted to remove 19, so we should have stopped at 2. While index is less than position minus 1. So I had it right at first, I think. Alright. Well, this was called me being upset, me being aggravated, me being cranky, and not following proper procedures and clouding my mind with emotion. I think I just finished it potentially. I don't know. What are you doing, Hacker Rank? You gonna finish, huh? Bruh. This is BS, man. Alright, so it wanted us to remove an element at what? Oh, that's the output. At element 0, and this is 0 indexed. So while index is less than position minus 1. Index is 0, position is 0 minus 1, it's -1. This will never run. the start node is equal to the current node. Okay. The end node is equal to current node plus, I think we just need to add a little thing up here. If position is equal to 0, then what we're going to want to do is we're going to want to say the list equals the list dot next. Hopefully that'll fix this. Oh, because it continued running. Jesus, that's why. What the hell? I could use an energy drink, man. Alright, well, this should hopefully fix this. Alright, well, that turned out to be not exactly more difficult, but definitely more annoying than I was hoping it would be. You know what? I'm clearly struggling to do this. I'm just going to fucking speedrun these. I'll get done in like 2 seconds. You are given a pointer ahead of a linked list, an integer to add. Create a new node with the given integer. Insert this node at the tail of the linked list and return the head node of the linked list formed after inserting this new node. The given head pointer may be null, meaning the initial list is empty. How do you create a list? Can you point to none in memory? While current node data is not equal to none. You know what? That's probably fine. Current node is equal to head current node dot next. Current node equals current node dot next. Okay, you learn something new every day. And then we're gonna say node dot next. Oh shit, is equal to data. No, singly linked list node data. Beautiful. I feel like this might work. And now that I'm sober, and now I'm so high. Node dot next. That was stupid. That was stupid. Alright, in this problem, they kind of just decided to fuck me. I guess I need to start doing more checks like this in the beginning. That was stupid. That should not have went on as long as it did. There's always something, man. There's always something. I'm gonna check and see what my girlfriend said, 'cause I'm bored. Alright, despite my mental sanity, we are going to do another linked list question. Might as well just go in Nord at this point. Given the pointer to the head of a known linked list, insert it at a certain percent. No, whatever, I get it. Let me play some music. Music might help soothe the fucking pain. Ooh, this is hard. For eye and range. Well, actually, it's just blank and range. Or blank and range. Position. What we're gonna do is we're gonna say current nude is equal to the list. Current node equals current node dot next. And then when we get to what the heck is it called again? There it is. You are the rest of me is down. Fuck you. Your love. Now I've got you in my space. I'm latching onto you. Have you shock of it, my embrace. Latching onto you. I've got you in my space. You shock of it, my embrace. What? $13.7. And I want to insert 1, 2, 3. I want it. So I'm inserting 1. Hit me with an edge case. Do it! Do it! You won't do it! Just kidding. Oh, wow. I definitely thought it was going to hit me with some BS edge case. Oh, I should just click next challenge. Reverse a link. Oh, no. Print in reverse. Alright. Well, is that not the same as... Alright, whatever. I'm just going to initialize an array. Vals. Okay, values equals an empty array for while the list dot next is not none. The list equals the list dot next list dot data.
An object is not iterable.
Oh, what am I doing? That was dumb. Man, my brain must not be functioning very well today. Holy crap. My focus is definitely not there. Alright, well, I don't know if you guys seen, but basically this question's just stupid, so I'm gonna just implement something. Well, I'm gonna implement the thing that the people have here. Just because I want the points, honestly, and for it to be said that it's done. How does this even work, though? Whoa, I see, it's weird. Weird, okay. Yeah, I never would have thought of this, I'll keep it a buck. That's really cool, though. Yeah, that's really cool. I never would have thought of that. I didn't, even like reading it, I was like, this is boof, like this don't work. On to the next. So I think I'm gonna try to take a note from the question that we just looked at. Alright, so watching a YouTube video and like kind of effing off, just seeing what's up through while doing this. And this is where I'm at, and this doesn't pass, but I also feel like this is pretty close. So I'm returning. Well, I shouldn't return this. Should I? I feel like I should. This should end up being the head to a new list. So I feel like I should be returning this. The idea behind this is it's going to basically iterate until it gets to the end of the thing. So it's going to say if current node.next is not none, then it is going to run the recursive function and it's going to return it, right? So every time that it runs a recursive function, it goes a layer deeper, it goes one further into the thing, and it also keeps track of the previous node, and that way, as you can see, wait a minute, I think this should be happening up here. Yeah, it literally just like goes node to node. It keeps track of the previous node and the next node. And the idea is that, hold on, I'm drawing a blank. Recursion's sometimes kind of a difficult thing to follow. Okay. That's what happened here. Alright, so what this is going to do is it is going to basically go until it hits the last thing. So the only time the cell statement's going to run is at the very, like, when we get to the very end of the list, right? So otherwise, it's going to say if current node.next is not none, it's going to return the recursive function, and then it's not going to do this. Okay, I need to next node. Oh, damn it. And then I think we can take this right here and we can say the current node is equal to, yep. And this should allow us, hopefully, to do something. Whatever. I'm gonna see if I can hit this with a try except block. Ah! Time limit exceeded. Whatever, bro. God, this shit's gonna piss me off, man. So, next node is equal to none. It tries to assign next node. Why is this? Do not use bear except. Why? Alright. It's going to try to assign the next node. If the previous node is not none, then the current node dot next becomes previous node, and it's going to do that all the way through as it's going. So let me flip my camera. Alright, so as it's moving, it's going to say, okay, it's going to keep track of the next node, and then it's going to say, if the previous node is not none, then it's going to do something, and then it's going to say, if next node is not none, then it's going to call the recursive function again. And so, well, it's going to return the recursive function. In this case, previous node is none because there's nothing before it, but next node is not none, and so we move to this one. You know what? Actually, now that I'm looking at this, I guess that if previous node is none. Alright, well, I didn't need the extra if statement. I was able to just say current node dot next is equal to previous node. I don't need to check to see if it's empty because otherwise this one stays, I think, stays pointing this way, right? Yeah. Anywho, so that's solved, but then you get here, and previous node is equal to this. Well, it's going to try to assign next node first, and it's able to do that. And then it's going to assign its next node to this, which is its previous node. If next node is not none, which won't be in this case, then it's going to call another thing of recursion. And it's going to say, okay, we go here, and we repeat the same process until we get to the end. Now, all of the arrows are flipped going this way. This is pointing towards none. And we get to the end, and it says next node is equal to none, and it tries to assign it to current node.next, but that's going to become none. Current node.next is equal to previous node, so hopefully this arrow should flip and face towards the previous, which, you know, is past the thing. And then if next node is not none, which it is, so it's not going to run, otherwise it's going to return current node. So this is going to get returned, and then each of these are returning the function call before it, and so it should get propagated back up to the start. That is the hope, but I'm still working on implementing that to actually work, I'm pretty sure. Oh, shit, well, I guess we solved something. I guess if you work through paper well enough, you'll eventually solve it, because we passed 2 test cases there. I hate when they hit me with edge cases. They might do it again, but I just don't feel like thinking about it. Like, if I was in an actual interview setting, sure, I'd think about edge cases. It's not hard. Alright, cool. Now, let's just go to... Oh, you guys can't even see. It actually worked. Let me just fix this really quick. I don't think this is efficient. I think you literally could just... Let's try something. I'm going to delete this. Current node dot next is equal to last node. All right, so let's see. We got last node and current node. Our current node dot next, if it's not none, then we're going to say the next node is equal to current dot next. We're going to say that the okay. Current node equals next node. The current node dot next is equal to the last node. Last node is equal to the current node. Current node is equal to next node. While current node is not none, because we need to make sure that the last one runs. It's going to say the next node is equal to none. The current node is equal, okay, so this needs to happen. The last node is equal to the current node. That's fine. The current node is equal to the next node. This is the condition that I'm worried about. Yeah, that's not okay. That's not going to fly. So for the last node, it's not going to be flipped. Node dot next is equal to previous node. Last node. Yeah. All right, let's try this. Cool. Damn, first try. Wow. Well, this was definitely a lot simpler than I made it out to be. I mean, I guess it was kind of interesting that I implemented a solution using recursion, even if it was wrong. You're given the pointer to the head nodes of two linked lists. Compare the data in the linked list to check if they are equal. If the data attributes are equal and the lists are the same length, return 1. It says data attributes. Okay, baby, be calling me Hercules cause I ate some more waste, but the bitches never heard me. Alright, so all I did was I made a small change to check and make sure that these two were equal. I think this is honestly a pretty good implementation, so we're just gonna keep rolling. Given pointers to the heads of two sorted merge them into a single sorted list. Either head pointer may be null. Okay. So I assume that means that each list is sorted, right? Okay, they are. Okay. So while I'm gonna just go ahead and say F memory here, and we're just gonna rock like this. So we're gonna say head. No, say sorted head is equal to singly linked list node. I think we'll just define its data here in a second. While head one dot next is not none and all right. That's weird. This I'm not understanding. Where is the none coming from here? Alright guys, so I've been off screen making a few changes because my headphones were dead and I never do anything without my headphones. And I just haven't been recording doing it. Today we are double fisting some mugs. We got water in one, coffee in the other. For hydration, for energy, you feel me? So, hell yeah. So where are we at with things? And what is the strategy behind what I'm doing? So, the very first thing is we have to keep track of the head of the list, right? And so we initialize a variable and we just create an empty node, right? And then we set our current node to be the head of our new list. And then from there we say while head 1 and head 2 are not empty, because there will be a different flow depending on that. But we could probably say or. I think we probably could say or, but by doing it this way we save like a pretty dramatic amount of time. So the first thing we do is we go ahead and just set, so by knowing that head 1 and head 2 are not none, then we know that our current node .next can't exist. We will in fact be able to find data to fill this, right? And so we say if head 1 .data is less than, basically we just take the lesser of the two values because it's a sorted thing, and then we push the head of our list to be the next thing in the node, okay? The next node in the linked list. And we do the same here. And then if there's the situation where both of them are equal to each other, we have to handle this accordingly. We have to say, okay, let's just take one of them. This could be head 2, it could be head 1, it doesn't matter. They're equal in this situation. And we say our current node's data is equal to that, and then we say the current node.next data is also equal to that. And then we increment both of them, right? Because they're both equal to each other, and we're just adding both of these to our list in one go. And lastly, we push our current node to be the next so that we can continue working. Down here, what we do is we say, okay, we've iterated through at least one of the linked lists, right? We're at the end of at least one of these linked lists, so we just need to figure out which one we're at the end of, and then we just need to append the last node. I think it's I'm curious. I think I'm right though. So my logic behind this is that if you had one list, right, it could all you know is that one is over and one is not, potentially. Otherwise you would just do nothing. Otherwise you're finished, I'm pretty sure. I would have to confirm that. But once this loop ends, assuming the lists are not the same length, well, even if they were, it doesn't guarantee. Okay, yeah. So I think it's pretty much a guarantee that unless both lists are equal length, well, no, unless both lists have the same last value, this condition is going to run. It's going to say that, okay, if one list is not finished, then I want to make my next node equal to the head of the other list, which, mind you, is not the actual true head of the list, right? So we're not just adding like the beginning of a list to our current list. In theory, what I'm trying to accomplish here is I'm trying to take the head of the list at some point, you know, that we've basically the remaining portion of the list after we iterated through both. And so if we're looking at what that looks like here, in the very first nodes of both of these, head 1 has 1, head 2 has 3, okay? So then we append head 1, which is where we get the output 1 here. We look at head 1 data and it's 2, so then we add 2 because it's less than 3. and then we say, okay, both of these are equal to 3, and so we append both of the 3's. Lastly, we get to this thing, and we say, okay, if head 1 is not none, and I really couldn't tell you which one isn't none. One of these is just not none, though, because basically this condition exits right at that point. One of these has to be none. And it sets the current node to the point that we left off. And it should append the rest of the list, but it might not, so I can't say for sure. Oh, this is interesting. So I got this right, it looks like, but it seems that I just accidentally added a none at some point there. I don't know how this happened, but we can try and understand it. So head 2 should get appended, or yes, head 2 should get appended, so it'll be 1. Again, head 2 will get appended, should be 2. Head 1 should get appended this time, it'll be 4. Head 2 is 10. Oh, and then, no, we'd go down here, append head 5, head 6, and then head 10. But at some point, it must be this point, no? How do I end up adding a none node? This makes sense, right? Like, I can understand why there's a 10 after the none here, but where is the none coming from? The scenario in which we're assigning current node.next is here. But that does necessarily, I feel like, so one thing I'm starting to wonder is, should I be looking to go 2 nodes in the future from this point? So there's a lot of extra logic going on here for this. I feel like I need to push this to be the next node, and then I need to create another node and push to that one. That's a lot of logic there. Alright, this one's unnecessary. Alright, so it's going to set our current data as you would in all the other ones. It's going to set the current node to be the next. And the next node exists. But the current node.next doesn't exist yet, so we make it exist. And then this should have something to go to. I hope that doesn't trip anything up. I'm going to run this, and hopefully it doesn't mess up the first test case. And it does. That's quite annoying. And it creates a none thing there. And I'm almost wondering, this kind of has to be the case. We kind of have to assign the next variable. There's nothing else we could assign, really. Next node, I mean. Alright, so why does this fail? Let's just step through this really quick. So we get head 1, head 2, head 3, head 3. Okay, so it ends up at this condition. And when it gets to this condition, the state that we would be in is we have created, I think, 2 nodes. Current node.data, head 1.data. Current node.next.data, head 1.data. Okay, so this assigns the 2 3's, right? So we're good at this point. But after this point, we say current node equals current node.next. So our current node is 3. So we go to the next. Our current node is still equal to 3, and we don't have a next yet. This creates the next node. This pushes us to the next node, which is now none. So I want to take this out, but if I take this out, then this no longer makes any sense. But if I could just remove this, then this is going to work properly. Alright, what I'm kind of wondering is maybe what I do is I delete all of this. I say else, run this unconditionally. We take either of the two. In this case, it'll be current data dot the second one, right? And then we say dot next. I think this still has the potential to ruin what I'm doing here, because we could still get down to this point and have a current node dot next be empty, and beyond that current node dot next we could still potentially just never assign it. So this needs to run after this, because we need to define what's in this first. Oh, man. No, I can't. But I was honestly pretty close. Okay. So, I don't really understand how this is happening. I'm gonna go ahead and just comment this out to see if I actually don't quite. Okay, it does make sense that this would be none if I commented this out, but this shouldn't be none otherwise. We should never end up with a none though, because this makes sure that there's two different assignable values. It means this will always, one of these is going to fill our current node, and then we'll still have at least one left to fill the next. So I don't actually understand how this could ever come to be. I mean, it says what it says. Alright, well, let's just step through this. Alright. Head 1, I don't really feel like stepping through this. So it adds the first 3 here, adds the second 3 here. Head 1 is none. Head 2 is 4. At least it should be. And it would have the point, it would have ran this first, I think. It should have, yeah, it should have ran that first, and then on the very last one it should have ran this one. And when it runs this, it's going to first create a next node, empty. It's going to assign our current node. It's going to push us to our next node, which is empty. And then it should have said our current node should become head 2, but it doesn't ever do this, does it? Ran. Okay, no, it does do it. Then how are we ending up with a none here? Dot. Next. Alright, so all that we're doing differently here is, instead of just changing the memory address of the last empty node, we're just making it, we're copying data from the lists, which I think I've done that all the way through. I have. I don't know why I decided to get all frisky down at the end. This should fix it. But it's not, I don't think it's going to fix it in everything. I think it's going to fix it in most cases. And it fixes it in no cases, so that's pretty cute as well. In JavaScript, you could use like a question mark, and it would assign it here. But I don't know if you have such a thing in Python. You really have to like work on the actual data, and you're working with memory addresses, and you're working with pointers, and I mean maybe it's because I'm out of practice with C++, but I'm not a huge fan of doing that. I think it's a little bit redundant. I think that it's inefficient. I think it's added complexity that a programmer shouldn't have to deal with unless they're writing super low-level systems. Oh, cool. Okay, so there is one scenario that I wanted to point out, and I think we might have fixed it by removing this last statement. I'm actually kind of curious. Let's just go ahead and run this and see what happens. Cool. Okay. Well, that's over with. Let's ask ChatGPT how it would do this best case most efficiently. You know what? Before even asking, I kind of want to. Yeah, I don't know. I personally, I'm not sure that I even like its implementation more than I do, or like more than my own. I mean, this is like so slightly less efficient. I mean, this is like maybe 2 more operations. So yeah, I'm not really concerned about it. We did pretty good on this. Yeah, so this is actually a continuation of another video I did. So I'm gonna go ahead and cut it here because I think we're pushing like 2 hours and 30 minutes at this point. Bye bye.